Modern refrigerators are supposed to last 10 to 15 years. Most are now engineered to fail well before that window closes. Not because the engineers couldn't do better, because they chose not to. There are 15 distinct design decisions buried inside the average refrigerator sold today, each one quietly ensuring that when something goes wrong, your only real option is a new unit. Sealed systems, proprietary firmware, glued assemblies, parts that don't ship to third parties. Walk through all 15 of them and you'll never look at an appliance warranty the same way again. Before we move on, please take a moment to subscribe to the channel and like the video. Number 1. Sealed compressors that can't be repaired. The compressor is the heart of a refrigerator, a steel canister roughly the size of a bowling ball, running continuously for years without a single service interval. In older machines, that canister had a service port. A technician could open it, swap the valves, recharge the refrigerant, and walk away. The fridge ran another decade. The sealed compressor inside most refrigerators built today doesn't have that port. The shell welds shut at the factory under controlled conditions no repair shop can replicate. So when it fails, the only certified path forward is a full compressor swap, running $300 to $600 in parts alone before labor. Manufacturers will tell you the sealed design improves reliability. What they won't tell you is that it also converts what was once a $40 valve repair into a $500 minimum event, with no gradual repair path available anywhere in between. Number 2. Proprietary parts only available to manufacturers. Walk into any independent appliance repair shop and ask for a control board for a mid-range Samsung or LG refrigerator built in the last 5 years. The technician will either laugh or hand you a phone number that connects to the manufacturer's parts line, where the quoted price makes the repair financially irrational before the call ends. The circuit boards, sensor assemblies, and valve bodies inside these machines aren't sold through third-party distributors and won't interchange with generic alternatives. The part exists, sitting in a manufacturer-controlled warehouse, priced without competition. A temperature sensor is a resistor in a housing. It could be standardized the way fuses are. The decision to make it proprietary is a supply chain choice, and in 2021, the FTC named it plainly: a market distortion that pulls money from owners toward manufacturers. Number 3. Software locks blocking third-party repairs. Independent technicians across the country describe the same moment with the same frustration. They've diagnosed the problem, sourced the part, installed it correctly, and then plugged the refrigerator back in. Nothing happens. Not because the repair was wrong, but because the control board doesn't recognize the new component. Modern refrigerator firmware includes authentication routines, code that checks whether installed parts match the manufacturer's registered configuration. When a third-party part fails that check, the board refuses to initialize it or flags a fault code that shuts the cooling system down completely. Apple ran this same playbook with iPhone screens. John Deere ran it with Tractor software. The appliance industry watched both battles closely and implemented identical locks, without facing anywhere near the same political pressure to stop. Number 4. Plastic components replacing durable metal parts. Pull the back panel off a refrigerator built in 1975, and you'll find stamped steel brackets, aluminum evaporator coils, cast components machined to tolerances designed for decades of thermal cycling. Pull the back panel off one built in 2020, and you'll find injection-molded ABS plastic, and not the heavy-gauge industrial kind. The substitution happened over 30 years, driven by cost-per-unit targets, not performance data. In a factory producing 2 million units annually, a 40-cent reduction per component moves the quarterly numbers. The problem is that plastic fatigues inside a refrigerator in ways metal never did. Brackets crack. Fan mounts develop hairline fractures that send vibration migrating through the chassis. Drain pans warp and pool water where it was never supposed to reach. Number 5. Built-in obsolescence through cheap electronics. The control board inside a commercial refrigeration unit gets specified for a 25-year service life. The one inside your kitchen refrigerator gets specified for a price point that lets the unit retail at $1,100 at a big box store. Both boards manage compressor cycles and read temperature sensors, but the components inside them aren't remotely equivalent. Electrolytic capacitors, the small cylindrical components that regulate voltage on the board, carry rated lifespans of 2,000 to 5,000 operating hours. A refrigerator runs continuously. Do that math, and you get a component statistically due to fail somewhere between years 5 and 8. Electronics specialists who work on these boards have documented the pattern consistently. Bulging, leaking, open-circuit capacitors at the 5-year mark. The fix takes 20 minutes and a $3 part. But manufacturers won't sell you that part. Number 6. Firmware updates that disable older units. In 2022, owners of certain LG smart refrigerators discovered their units had stopped connecting to the ThinQ app after a firmware update pushed silently over Wi-Fi. For some models, that app connection wasn't a convenience feature. It managed temperature zones, and without it, the refrigerator defaulted to a single flat temperature that started spoiling food faster. Smart refrigerators receive over-the-air updates the same way smartphones do, but without the army of tech journalists and consumer advocates watching what those updates actually change. Most owners never know an update ran. The legal position manufacturers take is straightforward. The software was always licensed, not sold. The terms of service allow modifications at any time, and your warranty won't cover what a firmware update quietly does to your compressor cycling after it expires. Number 7. High repair costs forcing full replacement. The evaporator fan motor is a brushless DC motor about the size of a fist, sitting behind the freezer wall, moving air across the coils. In a 1990s refrigerator, it bolted to a bracket with 2 screws, wired with a standard connector, and any parts distributor stocked it for around $25. 30 minutes of labor, done. In a current generation unit, that same motor is buried inside a sealed module containing the evaporator housing, the defrost heater assembly, and the thermistor harness. Accessing it means pulling the interior back panel, the freezer shelving, sometimes the ice maker. Labor time jumps from 30 minutes to 3 hours, not because the fan got more complex, but because the architecture around it was never designed to be opened by anyone other than the factory robot that closed it. Number 8. Limited access to diagnostic tools. A commercial refrigeration technician walks up to a failed industrial unit, plugs into the service port, and reads everything. Fault history, refrigerant pressures, compressor cycle data, sensor logs. Open protocol. Any certified technician with the right equipment gets the full picture. Consumer refrigerators generate that same data. Fault codes, temperature logs, compressor runtime hours, defrost cycle records, all of it sitting on the control board. LG's diagnostic system requires a manufacturer-authorized account. Samsung's error code database isn't published anywhere. Whirlpool's diagnostic mode on newer units needs a dealer-level access code to read anything beyond the basic error number on the panel. So, an independent technician replaces a thermostat when the real problem is a compressor throwing overcurrent faults for 6 months. The thermostat fix fails. The owner pays twice. Number 9. Glued components instead of screws. There's a moment in a refrigerator disassembly where a technician reaches for a screwdriver and finds nothing to drive. No fastener, no clip, no visible seam. Just a smooth panel bonded to the frame with industrial adhesive that was never designed to release. Structural adhesives spread through refrigerator assembly over the past 15 years because they're faster on a factory line than screws. No alignment jigs, no torque specs, just a bead of adhesive and a pressed joint that passes quality control. Door liners, evaporator covers, rear service panels, all bonded in a growing number of models. A technician needing to reach the evaporator coils behind that bonded cover gets 2 choices. Pry it and crack the plastic liner, or order a full replacement panel assembly and add it to the estimate. Number 10. Short warranty periods hiding long-term failures. The standard refrigerator warranty reads like reasonable protection. 1 year covering parts and labor, 5 years on the sealed system. What it doesn't tell you is when the failures actually show up. Control board failures, compressor failures, sealed system leaks, these have median onset times of 5 to 8 years from purchase. The 1-year comprehensive coverage expires long before any of that becomes statistically likely, and the 5-year sealed system warranty covers the compressor but not the $200 to $400 labor bill to swap it. Extended warranties exist because everyone in the industry already knows this gap is there. The manufacturer collects the premium, pays the claim when the failure arrives on schedule, and profits on the spread between the two. Number 11. Supply chain delays for replacement parts. Part number D, A31-00146E. Fan motor assembly seized. Listed as available on the manufacturer's website. Estimated delivery, 6 to 14 weeks. 6 weeks without a refrigerator isn't a supply chain inconvenience. It's a purchase decision, and manufacturers understand that math precisely. Parts for current generation refrigerators get produced in low volumes because the production model assumes most owners won't repair. When repair demand spikes, availability collapses fast, and sometimes the delay isn't about production capacity at all. Independent technicians have found parts listed as available that are actually on permanent backorder. The listing kept active because removing it would trigger disclosure obligations in certain states. The part exists on the website. The refrigerator sits warm, and the owner drives to the appliance store because 6 weeks simply isn't negotiable. Number 12. Energy efficiency designs that sacrifice durability. The ENERGY STAR label on a modern refrigerator isn't a lie. Current units genuinely consume far less electricity than anything built in the 1990s, and over several years of operation, that difference shows up on your power bill in a real way. The engineering that gets them there, though, carries costs. The label doesn't print. Tighter insulation foam means thinner cabinet walls with less structural rigidity. Variable speed inverter compressors modulate their output constantly to match the cooling load, which saves electricity but adds an inverter board to the machine. A component that didn't exist in single-speed designs and costs $200 to $500 to replace. Those efficiency gains arrive early. The inverter board failure arrives at year 6, well after the warranty closed. Number 13. Non-modular design making small fixes impossible. Industrial refrigeration has run on modular design for decades because it works. A compressor module fails, you pull it and swap it. The evaporator module needs service. You access it independently without touching anything else. Each assembly exists as its own serviceable unit, so a small failure stays small. Consumer refrigerators abandon that logic. The ice maker in most current generation units is a single sealed assembly containing the water inlet valve, the ice mold, the ejector motor, the thermostat, and its own control board. When the ejector motor fails, which it does more than any other ice maker component, you can't pull just the motor. It costs $8 as a standalone part. Inside the integrated assembly, that $8 motor triggers a full replacement costing $100 to $250, plus labor. Number 14. Manufacturer refusal to sell parts directly. In most states, no law requires an appliance manufacturer to sell replacement parts to anyone. Not to consumers, not to independent shops, not to anyone outside their authorized network. The manufacturer can list the part on their website and simply decline the order, with no explanation required. Several major manufacturers run tiered distribution systems where control boards and sealed system components only ship to technicians who've completed manufacturer training programs and paid certification fees. An independent technician who hasn't cleared those hurdles gets a declined order. Consumer Reports documented cases where owners were told the part wasn't available for consumer purchase, that an authorized technician was required, and that the nearest one had a 3-week wait. At that point, most people don't wait. They buy a new refrigerator. Number 15, planned life cycle engineering. 5 to 7 year lifespan. Buried inside the engineering documentation that never reaches a consumer, there's a number called the design life. For most refrigerators built by major manufacturers today, that number sits between 5 and 10 years. Not 15, 5 to 10. Design life isn't a marketing term. It's the engineering target that governs which capacitors get specified, what plastic grade goes into the brackets, how many thermal cycles the door gaskets get tested to survive. Set the design life at 7 years, and every component gets selected to be adequate for 7 years, nothing more. Manufacturers don't publish these targets, but they surface in product liability litigation, in engineering documents pulled through legal discovery. The refrigerator sitting in your kitchen right now carries an expiration date its manufacturer calculated before ordering the first component. 15 decisions, each one defensible on its own. Welded compressors, proprietary boards, firmware locks, adhesive bonded panels, capacitors rated to expire just past the warranty window. Taken separately, they read like engineering trade-offs. Taken together, they form a system that transferred ownership of the appliance from you to the manufacturer the day it left the factory floor. Right to repair legislation is moving through 14 states. The FTC is pushing enforcement. The EU is writing repairability floors into law for appliances by 2026. None of that touches the machine already running in your kitchen. A $600 fan repair isn't bad luck. Someone calculated it,